The irony of casually watching a YouTube video on a computer more powerful than anything humanity could have imagined just a few decades ago. This progress, along with all the wonderful machines we often take for granted, is built on a foundation of rare and precious materials with names like terbium, neodymium, or tantalum. However, the process of extracting these materials from the ground to incorporate them into our devices is far from pretty. The mining industry responsible for sourcing these materials often leaves a trail of environmental destruction in its wake. Air and water pollution, as well as the devastation of entire landscapes, are common side effects of traditional mining practices. Dangerous chemicals like cyanide, sulfuric acid, or chlorine are frequently used in the extraction process, harming biodiversity, workers, and local communities. Additionally, these rare resources can become political tools, with countries sometimes restricting access to them to achieve their own goals. But what if there was a way to replace this destructive mining industry with a clean process that poses no harm to anyone? Surprisingly, there is. All we need to do is look up. Introducing asteroid mining. Asteroids, those celestial bodies scattered throughout our solar system, are composed of millions of trillions of tons of rocks, metals, and ice. These remnants from the formation of our planet 4.5 billion years ago vary in size from small meters-wide rocks to protoplanets the size of entire countries. While most asteroids are concentrated in the asteroid belt and the Kuiper belt, hundreds of thousands more roam independently between planets. As advancements in space travel make it increasingly feasible, scientists and economists have begun exploring the vast resources hidden within these asteroids. Even relatively small metallic asteroids could contain trillions worth of industrial and precious metals like platinum. Larger asteroids, such as 16 Psyche, could contain enough iron-nickel to meet the world's metal needs for millions of years. At current market prices, the rare raw materials found in asteroids could be worth quadrillions of dollars. Well, not really, but technically speaking. To put this into perspective, there are more than 20 million tons of gold dissolved in the Earth's oceans, valued at roughly 750 trillion US dollars. However, extracting this gold would be so costly that it would actually result in a net loss. Similarly, asteroid mining faces a similar challenge. While there are billions of dollars worth of valuable resources in space, they are currently economically unviable to extract, costing trillions to do so. So what makes asteroid mining so challenging? The basic principles behind mining an asteroid are straightforward. Select an asteroid, move it to a location where processing is feasible, and then break it down to extract useful products. However, the cost of transporting materials from asteroids back to Earth, among other factors, makes this process prohibitively expensive at present. Unfortunately, these exciting possibilities collide with some fundamental challenges that humanity has yet. One potential solution is to transition from traditional rockets to electric spaceships. While electrical rocket engines are currently used in many space probes for scientific missions, they are not yet powerful enough to launch a spacecraft into space. However, once in space, these engines require only a minimal amount of fuel to travel long distances. This means that instead of spending a significant portion of the mission's budget on fuel, we can focus on transporting the necessary equipment and personnel into space. Asteroid processing. While this transition to electric propulsion doesn't solve all the cost issues associated with asteroid mining, it does make it more feasible to begin our first mission. With an electric asteroid mining spaceship at our disposal, the next step is to identify the right asteroid and transport the spacecraft to its location. Fortunately, we have already successfully visited asteroids with space probes and even collected samples from them. However, To make the process more efficient and cost-effective, our initial targets will likely be near-Earth asteroids, those that orbit relatively close to our planet. After months of travel, our spaceship finally reaches its target asteroid. These asteroids, often oddly shaped and littered with small impact craters, have remained largely unchanged for billions of years. The first task is to stabilize the asteroid and prevent it from spinning, which can be achieved through methods such as vaporizing material with a laser or using thrusters to slow its rotation. Once the asteroid is stable, we must wait for the optimal moment to act. Orbital mechanics are complex, but with precise timing and minimal force, we can move large objects. Our spaceship carefully nudges the asteroid into a trajectory that brings it near our moon, utilizing the moon's gravitational pull to put the asteroid into a stable orbit around Earth, saving even more fuel in the process. Throughout this process, the time since our spaceship was launched has not been wasted. Space mining and processing equipment have been installed in orbit and are now being maneuvered towards the asteroid. The processing equipment operates differently than on Earth, utilizing innovative techniques to extract valuable resources from the asteroid. Giant mirrors focus sunlight to heat up asteroid rock, boiling out the gases trapped within. Grinders then break up the dried rocks into gravel and dust, while centrifuges separate the dense elements from the lighter ones. Even if we only extract a tiny fraction, like 0.01% of the asteroid's mass in precious metals, it's still several times more than what you'd get from the same amount of ore on Earth. But how do we safely bring these precious metals back to Earth? One option is to load them into reusable rockets that return to Earth from space. Alternatively, if our processing facility includes 3D printers, we can use them to print heat-shielded capsules filled with gas bubbles. These capsules can be dropped into the oceans, where ships can tow them away, providing a faster and cheaper delivery method. This could mark the beginning of humanity's first real steps toward colonizing the solar system. As our infrastructure and experience in space mining grow, our missions will become more sophisticated. As the space industry expands and precious materials become more accessible, we could potentially cease mining on Earth altogether. The concept of toxic mining practices may become as outdated as having an open fire in your living room. Landscapes currently ravaged by pollution could begin to heal, while the technologies we rely on become cheaper and less environmentally harmful to produce. This vision of asteroid mining is not science fiction. We don't need new materials or physics breakthroughs to make it happen. We could start building this future today. All we need is an initial push to get us there.